Welcome everybody to another day of our second unit of the school year. In our previous lesson, we talked about one method of being able to graph a log equation, and namely we used the inverse equation to figure out what the actual graph ended up looking like. So today we're going to be looking at a second method in how to graph a log equation. Some of you might find this method easier, some of you might like the first method more, but at the end of the day, it's totally up to you which one you like more and which one you prefer to use. So you'll see from the objective basically what this method is going to encompass. So I can graph logarithmic functions by using a table of values to determine points on said curve. Okay, so that's our objective for today, and that gives you a pretty good preview of what our method would look like for today. So we're looking at the same function equation that we did in the previous lesson, which was f of x is equal to log base 3 of the quantity x minus 7 plus 2. Okay, so that's the exact same equation as the previous lesson. We're just using a different method to come up with the same graph. So this time around, instead of finding the inverse equation and finding those points and then just switching the x and y values when we wanted to find the actual function equation, this time we're just going to jump straight into the actual function equation using a table of values. Okay, so we're going to fill out this table using x values that we determine. Now, this method, in some ways, you have to be a little bit more careful. You have to be a little bit careful, which is why some might not like it as much as the first one. The x values that we pick. We have to be careful of the x values that we pick. I will give you an example really quickly. For example, let's do, I'm trying to think of one. Let's do x is equal to 6. Okay, let's do x is equal to 6. So if we make x is equal to 6, let's just plug it into our function. No, that's good. So let's see. We end up with log base 3 of 6 minus 7 plus 2. Okay? So 6 minus 7 is negative 1. So log base 3 of negative 1 plus 2. Now the thing is, if you try plugging into your calculator log base 3 of negative 1, and just a reminder, the way we would do that is we would type in log of negative 1 divided by log of 3, it would give you an error because log base 3 of negative 1 is undefined. It's kind of like dividing by 0. There is no value to it. And since there is no value to it, that means we cannot plot a point because there's no y value to our point. So that doesn't work. So you have to be careful what x values you pick. The conditions or the requirements of what x value you pick is that you have to make sure that whatever you're taking the log of, okay, so whatever you're taking the log of has to be greater than 0, okay? So we can't pick any x values that make our value that we're plugging in for log less than 0. So that's why if we picked 6 minus 7 is negative 1. We cannot take the log of negative 1. Same thing would happen if you tried 5 or 4 or 3, so on and so forth. If whatever you're taking the log of is negative, we cannot evaluate that. It is an undefined value. So it has to be positive. It can't be 0 either. So x is equal to 7 doesn't work either. If we plugged in 7, we get 7 minus 7, which is 0. So that doesn't work either. So it has to be positive. It has to be greater than 0. Okay, so we know that, at the very least. We know that. And I'll talk in a second why it has to be greater than 0 in a moment here. So I'm actually going to show two different ways you can think about these x values, two different ways. So the first way. we're going to choose x values in such a way where we end up with powers of 3. Okay, so we're going to choose x values in such a way where we end up with powers of 3. So what I mean by powers of 3, I mean like 3, 9, 27, powers of 3. Now, the reason why we want to do that, well, for those who did the extra credit assignment on Khan Academy, I think I want to say about a month back, it might be a little bit more than that, you would understand why this is the case. So let's do one example. Let's just stick with red. So let's say a power of 3 is 3, right? 3 to the first power is 3. So let me just put it off to the side here. So 3 to the first is 3. 3 second is, 9. 3 to the third is 27, so on and so forth, right? Oh, we could also do 3 to the 0. That's a power of 3, just ends up equaling 1. So let's do 3, right? 3 to the first is 3. So now careful. I want the inside of this parentheses to be equal to 3. So in reality, what I'm going to be plugging in is 10. I'm going to be plugging in 10 because I want 3. Okay, so 10 minus 7 is 3. Well, how does that help us? Well, log base 3 of 3 can be easily evaluated. Yes, you can just plug it into a calculator, perfectly fine. But it can be easily evaluated. Log base 3 of 3 is actually 1. So log base 3 of 3 is actually 1. Like I said, for those who did that Khan Academy extra credit assignment, you would recall the reason why it's equal to 1 is because log base 3 of 3 is the same thing as asking 3 to what power is equal to 3? And the answer is 3 to the first power is equal to 3. So that is why log base 3 of 3 is equal to 1. Or once again, just plug that into a calculator. So that means we end up with 1 plus 2, 3. Okay. Let's try a different one. So let's stick with these powers of 3. So let's try 9 next. Let's try to make sure that whatever's inside the parentheses is 9. So let's see. We have minus 7. So we want 9, but whatever we plug in is subtracted by 7. So if we want 9, that means we would have to plug in 16. Because once again, 16 minus 7 is 9. So that gives us log base 3 of 9 plus 2. And now we end up with the same situation. We end up with 2. So log base 3 of 9 is equal to 2 because 3 squared is 9. So 3 squared is 9. So if I were to, hopefully I could do this off to the side here. So 3 to what power is equal to 9? Well, if x is 2, it makes it equal to 9. So that's how we know log base 3 of 9 is 2. So that means when I plug in 16, I get 4. Because that's what we made our x value. We made our x value 16, so that 16 minus 7 gives us that 9. Well, the problem is that would not fit on our graph. So I'm probably going in the wrong direction. So let me go in the other direction. So let's see. I did 3 to the first power. I did 3 to the second power. Let's do 3 to the 0, 1. Okay, what would I have to plug into this equation? To get 1? Well, here's another way to think about it. If you're struggling a little bit with this idea of, well, how do I get this number if I'm always subtracting by 7? Just do a simple equation. Just do, all right, I want whatever is inside to equal 1. So I'm just going to set up an equation. So x minus 7 is equal to 1. Well, I can solve this by just adding 7 to both sides, and I get x is equal to 8. So that's what I want to plug in. I want to plug in 8 into my equation. I want to plug in 8 into my equation. To get 1. So log 8 minus 7 is 1, so we get log base 3 of 1 plus 2. And once again, log base 3 of 1 is 0. So you get 0 plus 2, which is 2. Use blue. Okay, so log base 3 of 1 is 0 because... kind of running out of room here. Because 3 to the 0 power is 1, right? So if we take this, 3 to what power is 1? It's 0. 3 to the 0 power is 1. Okay, so that worked out. Well, anything else? Well, at this point, we could do the negative exponents. We could start doing the negative exponents. Well, like, for example, we could do, well, 3 to the negative first is 1/3. Well, how do I get 1/3? Well, let's see. What color have I not used? Blue. I used blue yet. Well, let's see. So if we want the inside to be 1/3, that means add 7 to both sides. Get x is equal to 7 1/3, right? Because 1/3 plus 7 is just 7 1/3. So that means I want x to be 7 1/3. So log base 3 of 7 1/3 minus 7 plus 2 is going to give me, so 7 1/3 minus 7. So log base 3 of 1/3 plus 2. So 3 to what power is 1/3? Negative 1. 3 to the negative first power is 1/3. Plus 2 gives me 1. So negative 1 plus 2 gives me 1. And there. Now, for some of you thinking of it in terms of like these powers of x, right? These powers of x might be a little bit confusing, which is perfectly fine. At that point, as long as you're, if we go back to that requirement that I spoke of, as long as you're making sure that whatever you plug in ensures that you're taking log of something greater than 0, then you're fine, right? So let's say, for example, I think we didn't try 9, right? So let's do one more here. Let's try 9. You know, 9 minus 7 gives you 2, so it's greater than 0. That's good. So at that point, let's see how we can do that one. So log base 3 of 9 minus 7 plus 2, log base 3 of 2, because 9 minus 7 is 2, plus 2. And at this point, we're just going to plug this into a calculator. Since 2 is not a power of 3, we can't do it any other way. So we're going to do log of 2 divided by log of 3 plus 2. So let's see what we get. For that one, we get, so we just plug that into a calculator. Get that here. Log of 2 divided by log of 3. So that gives me, and I'll add the 2 as well. Actually, yeah, I'll add the 2. So I did log of 2 divided by log of 3, and then plus 2. So if I round that to 2 decimal places, that gets me 2.63. So at that point, let's just plug it into your calculator. So 2.63. So there you go. And then maybe if we wanted to do one more, let's see, what could we do? So we can't do 7 because 7 minus 7 is 0. We can do, let's say, 7.5. And at that point, I'm gonna speed through this a little bit more. 7.5 minus 7 is a half. So that is log base 3 of 0.5 plus 2. So log 0.5, log 3 plus 2. So that gives me 1.37. Okay, so the ones written in black, that was just simple using a calculator, just making sure that the x value that you plugged in gave you some value greater than 0. But the ones in red, orange, green, and blue, that's where we used these powers of 3 that you see in the top left here to help figure out what our x value should be. So we have our table of values. So now we can just plot these points at this point. We've got to plot each of these points. So I kind of forgot what the points were. So let's see. We had 10, 3. So that was in red, if I'm not mistaken. We had 10, 3. So 10, 3. We had, so 16, 4 was too big. 8, 2 in green. We had 8, 2 in green. And then we had 7 1/3. Wait, no. Yeah, we had 7 1/3, 1. So 7 1/3, 1. Wait, yeah. Right there. Okay, what else did we have? And then I think in black, we had 9, 2.63. 9, 2.63. Where are you? 2.63. So somewhere in there. And then finally, the last one we had was 7.5, comma 1.37. 7.5, comma 1.37. So somewhere around there. There you go. So now we can make our curve, which, once again, is the exact same curve as yesterday. There you go. All right. And you know what? I'm just going to reproduce the table here just to... So we had x, f of x... I think it was 6 points. Ten, 3, 16, 4, 8, 2. So 10, 3, 16, 4, 8, 2, 7 1/3, 1. And then those other ones with the decimals. 9, 2.63. And then what was it? 7.5, 1.37. So there you go. We have our graph. So we just plotted the points, and that's it. Nothing really special there outside of just the values that we ended up having to pick. And then don't forget, just like yesterday, do remember that this curve gets closer and closer as this curve goes down. It gets closer and closer to x equals 7, but never touches it. So remember, that is your vertical asymptote. Don't forget about that from the previous lesson. So vertical asymptote at x equals 7. Okay. All right. So just a recap, and that's it. We're done. Just a recap. You're just picking x values. Picking x values to plug into the equation. But once again, you do have to make sure that whatever x values you pick, they give you some value that is greater than 0 when you're taking the log of that value. Because once again, we tried 6 as our first value, or I think it was 6, but since we ended up with 6 minus 7, that's negative 1, we can't take the log of negative 1. It gives us an undefined value. You can only take the log of values greater than 0. Okay, so that's why we have 10, 16, 8, 7 1/3. And then, as long as you're paying attention to that fact, that you're making sure that you're taking a log of a value greater than 0, at that point, either you can use powers of 3, or whatever your base is. In this case, our base was 3. So that's why we did powers of 3. If your base was 2, then you would use powers of 2, so on and so forth. Or you just pick whatever x values you want and then just plug them into your calculator. So whatever obviously works better for you, go for it. But yeah, that's basically method 2. Nothing else to it, really. Okay, so just like the previous lesson, I would like for you guys to try out this next example on your own. So using the method that we just talked about, so log base 2 this time, of x plus 1 minus 2. Pick your x values. You just got to make sure, once again, you take the log of a positive number inside that parentheses. Then you plot your points, and you go from there. Do try to determine what the vertical asymptote is as well. Don't forget that part. And then from there, I have on the side here domain range increasing and decreasing. Just a little bit of review in terms of how to, if you can determine those after you draw your graph. Okay, otherwise, I hope this lesson went well. As usual, let me know if any questions do arise. But otherwise, I hope you guys enjoy the rest of your days, and I hope you